So welcome back to another part of learning about compounding. So here we'll talk about compounding over many years. Okay, using the formula from basically using this formula, we could derive by the future value is equal to your investment today, C1, plus 1 plus R M to the MT. T will be T years. Okay. T equals years into the future. Okay. So for example, if you invest $5,000 today, okay, at a APR of 12% per year, okay, and it's being compounded quarterly, okay, for 5 years. Okay, what is the wealth? So wealth at end of year 5. Okay. It just use the formula. So 5,000 times 5,000 times 1 plus at 12% APR over 4 quarters, 4 payments, 4 times 5 years. Okay, that'll give us 5,000 times 1.03 to the 20, which is equal to 5,000 times 1.8061, okay, which is equal to 9,350. Okay. That's not too bad. So the harder part is what if it's continuous compound? Continuous compound. Compounding. Okay. In a continuous compounding, okay, the value in T years at the end of T year is equal to your investment today, okay, times E to the RT. Okay. So Z is an investment, initial investment. Okay. R is the APR. Okay. T is the number of years. Over which investment rights. Okay. and E is the constant, or approximately equal to 2.718, I think. Okay. So, let's try. If you invest $1,000 today at continuously compounding, okay, compounded rate of 10% per year, okay, what's your wealth in the future? Okay, so wealth at the end of 1 year, okay, it's equal to 1,000 times e to the 10 equal to, after 1 year, you have 20. Okay. What if you invest for 2 years? So, same problem, but for 2 years. Okay. So, after 2 years, PV of 2 is equal to 1,000 times e to the 0.10 times 2 equal to e to the 20. So it's approximately equal to 1221.40. Okay. So how does the graph look like? It looks like this. So for annual payments, so let's try to illustrate the relationships among annual, semi-annual, and continuous compound. Okay, so if let's say if you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Biannual compounding. Okay. The dollar amount is, let's say you start with 1,000. Okay. So it looks like this. Okay. So these steps here is what they'll call interest earned. Okay. So in a semi-annual, so it's 1, 2, 4, 5. In my semi-annual, same thing. 1, 2, 3, 4. Okay. We start with 1, but every half a year it changes. Okay. So all these steps are interest earned. Okay. Now, in a continuous compound, what do you think the graph would look like? Oops. Continuous compounding. One, 2, 3, 4, 5. You have 1, 2, 3, 4. In a continuous compounding, it's not semi, it's not annual. It's actually, it looks like this. Let me draw it better. Okay. Where this length here. Okay. All of this is the interest earned. Okay. It's exponentially increasing. Okay. So let's take an example. So what's the present value with compounding, with continuous compounding? Okay. So let's say a state lottery is going to pay you It's going to pay you $100,000. Okay. At the end of 4 years. At end of 4 years. Okay. If the annual continuous compounded rate interest is 8%, so the annual continuous compounded rate of interest is 8%. What is the present value of the payment? So you could transpose the future value of a continuous compounding into present tense. So PV is equal to 100,000 times 1 over e to the 1.08 to the 4 years, which is equal to 100,000 times factor of 1.371, which is equal to a present value of 72,616. That ends continuous compounding.